All right, so I am not going down any more volcanoes. That was a rough ride. Just joking, but I do have an injury. I have a couple videos to make, so I just wanted to let you know in case it does show up. One of my passions is running. I run a lot. I run all the time. And with any sport, there's sometimes injuries. And this morning, I was running with Miss Norton and took a fall. Good news is I caught myself with my face. So my face is a little bruised up. Hopefully by the time I see you guys in person, it'll clear up. I got my hand a little bit too. Ms. Norton is very funny though. She left me a get well gift. I think we look the same. What do you think? So I just wanted to get that out there and couldn't resist the joke about the volcano. So I thought that was funny. Today we're gonna talk about the rock cycle. We've been talking about how what's going on underneath the earth changes the surface of the earth. It's also changing the rocks. Who would have thought that rocks are actually constantly changing? When something's in a cycle, that means it's going around and around. So with the rock cycle, that's exactly what's happening with the rocks. Now, I know we could sit here and stare at a rock all day long and nothing would happen to it. This process is very slow. So I'm going to talk to you today about how the rock cycle happens. All right, so have out your science notebook and your pens or pencils that you use for taking notes and turn to the next empty page. If you need to pause to do that, please do so. And we're gonna start off with a triangle. I'm gonna make it rather big because we have a lot of information to fit in there. There's my triangle. And on your triangle, at the top, I'm gonna draw a circle, and at each corner, I'm gonna draw a circle. These are gonna be our three types of rocks. There are three main classifications of rocks, and these classifications are made by how the rock is formed. So the rock is named by its formation. These three types of rocks we're going to learn about. We're going to label these circles with the names. I'm going to change colors. In this top circle, I'm going to write Igneous Rock. Remember, the beauty of doing these notes by tape is that you can pause it anytime you need to if you get behind. So my Igneous Rock, I'm going to do rocks at the top. Going down to this right-hand circle, if you could write Metamorphic Rock. I did not leave enough space, so I'm curling around. I'll spin my notebook a little bit so you can see it. Metamorphic Rocks. We know when something morphs, it changes. Again, pause it if you need to. And in that last circle, I'm going to label Sedimentary Rocks. All right, so like I said, once a rock does not mean it's always a rock. It's going to go through changes. And the changes in a rock cycle will make the rock change from one type of rock to another, and the formation of it makes it the rock it is. For example, igneous rocks. We're going to start with that. An igneous rock is always formed when you have magma or lava. Remember, we said that's melted rock. Magma rock is below the Earth's surface. Lava rock is above the Earth's surface. We have an igneous rock when this magma or that lava has cooled and hardened. To give an idea, we're going to do a little diagram. That's going to be my volcano. There's magma inside the Earth's crust. And we know when it comes above, that's my erupting volcano. We know when that melted rock is out of the crust. When that magma or lava cools and hardens, it forms an igneous rock. Okay? So we could have a metamorphic rock, could melt. So I'm gonna do an arrow. Let's say a metamorphic rock, an arrow pointing from metamorphic up to igneous. If a metamorphic rock melted and then cooled and hardened, that metamorphic rock would become an igneous rock. This should be an O right there. I started to write a B, it looks like. So if a metamorphic rock melts and then cools and hardens, it then becomes an igneous rock. Same thing with the sedimentary rock. If a sedimentary rock cooled and hardened, so I'm going to do an arrow from sedimentary pointing up to igneous. This time I'll put my arrow inside the triangle, and that'll make more sense why in a little bit. I'm going to spin this one around. Cooled and hardened. So if a sedimentary rock cooled and hardened, it would become an igneous rock as well. An igneous rock is one of our most common rocks around this area. Granite rock, which is what many of our driveways are made out of, that granite is an igneous rock. A lot of people have granite countertops, and that's when they've taken a piece of granite and polished it till it's nice and shiny, and it's beautiful when it's polished. That's a granite as well. Granite is an igneous rock. Interesting things happen when that lava or magma cools and hardens. If it cools really, really fast, then we have little small particles in there, okay? These little particles are caused by little bubbles of minerals inside the melted rock. Now, if that magma or lava takes a longer time to cool and harden, it allows time for those minerals to gather a little bit more. And so since they have more time to gather as it's getting hard, those particles we see might be bigger. So both of these rocks are granite. This one is considered a fine granite because the little dots of minerals are very fine. This one's considered a coarse granite. The minerals were able to gather more and give a bigger texture, bigger pieces of mineral. But they are both igneous rocks. Both of these were formed from cooled and hardened magma or lava. Okay, we're gonna go over to this side, the left side of the triangle. If this igneous rock was broken into pieces, okay, and we have a word for that. For something to be broken down, it's called weathering. And then erosion carries it away. At the very bottom of your notebook, I want to do a little extra picture demonstrating the difference between these words. Remember when I told you that there are some words that fifth graders mix up often? Weathering and erosion are one of those words that get mixed up all the time. So it's important that we take some time to realize the difference between the two. So let's say we have a rock. There's my rock. I'm gonna make him a happy rock. And if that rock is exposed to things like wind, rain, ice, it can be broken down into pieces. And when it's broken into pieces, it's called sediments. Sediments are broken pieces of rock. Sand at the beach, sand is a sediment. Sand is actually broken down pieces of rock. These sediments, let's show that broken rock. I'm gonna do, now a big rock is now broken into lots of little sediments. The process of that rock being broken down into sediments is called weathering. And as I mentioned, a lot of our forms of weather influence weathering. If you're ever able to go back and look at the gravestones in the graveyard here in town, if you go to the very, very back, They're the very old gravestones, like from the Civil War and before. And you'll notice that on some of them, you can't even read the words anymore because the rock has worn down so much. That's weathering that's happening on those gravestones. So weathering breaks it, and then erosion takes it somewhere else. So I'm going to do erosion here. Okay, weathering breaks it. Erosion is, again, can be influenced by the weather because it happens if we have a lot of rain, and rain can cause mudslides or can cause puddles or streams. Erosion is when those sediments are taken somewhere else. One way to remember it is to say weathering breaks it, erosion takes it. Okay, weathering breaks it, erosion takes it. Again, pause anytime you need to if I'm moving too fast. Now these little sediments that are carried away with erosion, they don't go forever and ever and ever. Eventually they are deposited somewhere else. Have you ever heard the adults in your house say that they need to go deposit money? That means they have money that they need to put in the bank to keep it safe, okay? It's put in a location. With erosion, the sediments are deposited in an area, maybe when the rain dries up and it's left behind. Here's my little sediments in a little pile. This process of that erosion being left somewhere new is called deposition. I'm gonna have to do an arrow over this way. Deposition. It's easy to remember because it has that word deposit right in there. We said, like, if you were to deposit money in the bank, you're leaving it there. Deposition, those sediments are deposited somewhere new. All right, now that we understand a little bit about weathering and erosion, this is a very big part in the rock cycle because we could have rocks that are broken up into little pieces, sediments, that could later become a different rock. So I'm gonna do a different color so this makes sense. This time I'm gonna do for the arrow from the igneous rocks, and I'm gonna point it down to the sedimentary. So from igneous down towards sedimentary. And I'm gonna spin my notebook this way so that hopefully you can see most of it. So what happens is that igneous rock is exposed to weathering and erosion. Which means that that igneous rock can be exposed to being broken down and carried off to other places, okay? Then when that happens, it's making sediments. It's not the new rock yet. Remember we said this is a rock cycle and it's becoming a new rock. When those sediments, I'm gonna draw some little circles to represent sediments. When those sediments land, they are deposited somewhere. They are eventually, or can be eventually, cemented together. Okay? When we have a rock that's broken down into sediments and then cemented together, it makes a new rock called sedimentary rock. Again, this kind of makes sense because we have sediments that make sedimentary rock. Do you see how that word sediment is right in the rock name? Sedimentary rocks are very easy to recognize because you can actually, or usually, you can see those sediments. I'm leaving this up for a minute so you can copy that down. This right here is called a conglomerate. Basically a fancy rock name for a whole lot of different rocks, pebbles, sediments, cemented together to make this new rock. Okay, if you look closely, you can see quartz pebbles, pieces of sand, all of these smaller sediments cemented together to make this conglomerate, which is now considered a sedimentary rock. All right, this has big particles in it. Sometimes the particles are very small. This is limestone, or excuse me, this is sandstone. Sorry about that. With the sandstone, this is actually red sandstone. We have tiny red pieces of sand that's cemented together to make sandstone. If we weren't in the middle of the pandemic and we were in the classroom, I would then pass this around so you could feel it. It actually feels like sandpaper. You can feel that sand in sandstone. Okay, it's sediment. The sand is sediment, cemented together to make a new rock called Sedimentary Rock. Okay, I want to show you another one. This one isn't so obvious, but it is a sedimentary rock too. This is called limestone. This is a very common sedimentary rock in our area because it's normally formed under the water. With limestone, we have all those sediments cementing together, but mixed in, we also have calcite. We have broken down pieces of shell and water organisms in there as well. And it is cemented in with it when it cements together. Sedimentary rock is where we're most likely going to find fossils. Often when we have those sediments cementing together, the remains of an organism could be underneath those particles, and it conserves or preserves the bones of the animal, which will later turn to rock and become a fossil. So we find fossils in sedimentary rock. Okay, so what can happen now? Have you ever noticed how it's almost like magic when you're baking cookies and you stick the cookie dough into the oven? And cookie dough by itself is wonderful. But then you bake it and you have this amazing cookie. It becomes something totally different. That's how metamorphic rock works. With a metamorphic rock, the rock is exposed to extreme heat and extreme pressure, and as a result turns into something completely new. It's like it gets baked. If you've ever done ceramics or clay, it's the same idea. We could have something we sculpt in clay, cook it in a kiln oven, and then you have something that's almost glass-like, a brand new material. Same thing with a metamorphic rock. I'm going to change colors so we can see what I'm doing. Find a color that'll show. All right, this time I'm going to do an arrow from sedimentary rock. I'm going underneath my triangle to metamorphic rock. When a sedimentary rock is exposed to heat and pressure, it becomes something totally brand new called a metamorphic rock. Let's add on there. It could also happen with an igneous rock. If an igneous rock is exposed, I'm going to draw an arrow, to extreme heat and pressure, it too can become a metamorphic rock. Let me show you a common example. All right, this rock right here, and I'm hoping you can see the layers in it. This is a sedimentary rock called shale, and it's literally like layers of mud, the sediments of mud that have cemented together to make this rock called shale. Okay, I'm trying to see if we can get right there. You can kind of see the layers on that edge. I'm not sure if it's showing up in my phone camera or not. So this is shale. When shale, again, sedimentary rock, is exposed to heat and pressure, it becomes a brand new, like super strong ultra rock. It becomes slate. This is slate right here. I'm using this example because slate is something we're very familiar with. You can still see some layers in there from where it was under extreme pressure. Slate is like what our blackboards, our chalkboards are made out of. You've maybe gone to homes or gardens which have little slate walkways, like walking stones laid out in their gardens or leading up to their house that are made out of slate. They're usually black and round and kind of flat. Some roof shingles are made of slate. Slate is very strong. So this would be the equivalent of this. If this was your clay sculpture, and then you put it in the oven and baked it, and it became this. So shale turned to slate. I did notice I missed one arrow on our rock cycle, and that was going from metamorphic to sedimentary. So we said igneous rock could break into sediments and become sedimentary rock. So could metamorphic rock. Even though metamorphic rock is a little stronger, it too could break into sediments with weathering and erosion. To make a sedimentary rock when those sediments cement together. Another common form of a metamorphic rock would be marble. We use marble in a lot of buildings, tabletops, statues. This is an unpolished piece of marble in its raw form. Like granite, marble can become very beautiful when it is polished and made shiny. All right, the rock cycle notes can sometimes get very confusing, so I'm going to post a picture of the completed page as well. I'm worried that on the video you can't see the different colors I use that help it make more sense, so I'm hoping when you see it in the picture, that'll help you out.